Hello everyone, I am Soumyashree Senapati, Assistant Professor at Vedang Institute of Technology. So, in this class, we will learn to calculate compound stress and strain in inclined plane. So, till now we have learned about what are the compound stress. Like if in case of any plane there is presence of both normal stress and shear stress, we will term that as compound stress. So, now we will find out this by using inclined plane. So, first of all, to find out compound stress, we have two methods. One is analytical method and another one is graphical method. Okay. So, firstly we will understand this analytical method, then after understanding it in analytical method we will go for graphical method. So, if we understand in analytical method, so first we will take one object, we will take one rectangular shape object. As till now we have learned that stresses are applied because of loading conditions. Stresses are applied because of loading conditions. So, to find out stress, we need to put some load here. So, here in this object, we have applied tensile load in x direction and named it as Px. Okay. So, first we have A, B, C, D. Now, in case of ABCD, to find out the stress, to find out stresses, we will need to have, we have one point. We will take one point. Okay, this is the point and we named it as O. Here, in this point, we will find out stresses. So, there will be stresses like in this direction, in this direction, in this direction, here, like a lots of stresses are acting in case of any object. So, till now we have known that stresses will act in a point. So, which plane it will act? First, we will see in a vertical plane. So, firstly we will take one vertical plane and just calculate the stresses. So, here we have the object ABCD. Okay. So, we have the point here O and now let us cut this here in vertical direction. Okay. So, this we can name it as YY. This is our figure 1. Okay. So, first what we have done till now, we have done one, we just take one prismatic body, like prismatic body it can change its shape and size. Okay. So, after applying stresses, now we need to find out stress in this point. Here force applied is Px. We need to find out the stresses at point O. So, we cut the object in vertical direction. Now in figure 2, okay, we will just separate this and this part. Let's, it is xy. So now we have two figures. Okay, if we got it here, so we will have what? A B Y X and X Y D C. Okay, so we have the force here Px. Okay, in case of any object, we have learned till now that there are some atoms present in it. Okay, so there are some atoms. When we got the section, there will be some bond between them. Okay, here we have the atoms like this. So there will be some bond between them. So they will attract each other. Okay, so now here when we separate these two bodies, so the forces will act like this, right or wrong? The forces will act like this, and in this plane also will act like this. So there will be the resultant force, we will take that as Px. Okay. Now in this plane to find out sigma x. Okay. So we will take the stress, as we know that stress is our force upon area. So which force we will take? Here we have the resultant force. So for force we will take the Px upon area. Sigma x equals to Px upon area. Okay. So as we are taking the stresses like compound stress. So till now we have the what? Normal stress. What about shear stress? Here we will see that there is no stresses acting in parallel to the object or along the object. So we take shear stress as 0. Okay. Now we understand the action of stresses in vertical section, and we have what? Normal stress and shear stress in vertical plane. But our topic is to find out stresses in inclined plane. So calculation of stresses in inclined plane. Okay. Now we will take that similar object. This object is in 2D condition. Okay. So name it as A, B, C, D. Okay. Now what? Now we need to cut this object inclinedly. Okay. So after first point is we cut the object inclined to the plane. Okay. And name it as xy. Okay. So here we will name it as xy. This is the figure A. So after cutting it with xy plane, xy section, we will have two parts of the body. Now we will have the structure like this and this. Okay. So here similarly there will be some formation of bond. Here unidirectional for unidirectional force stress is acting, that is Px. Also, like I have already said that there will be some bond between them, right? So they will attract them. So there will be forces acting like this. Okay. And also there will be the resultant stress. Here we named it as Px. Okay. So in this condition we will take just this part and name it as ABCD. Here the X, Y, Z, P plane will left out. Okay. Now in figure, this is your figure P. In figure C, we just see this ABCD plane. So okay. So here the Px stress is acting. Also this we can say it is our Px, the resultant stress. So due to this Px, this CD will form angle theta here. Okay. So also in this way there will be angle theta, right? So what will happen, this Px, the resultant force, will give us another two stresses. In this direction you can see here, you can see in this direction Ps and in this direction P theta. Okay. So now we have Px, P theta and Ps. So now we will see this figure C in 3D. Okay. In our figure C, figure D. So if we just zoom the object, what will happen? Here the object will be like this. So if we just draw the 3 dimension of the object, now it will be easy to calculate the stresses. Okay. So here okay. So we have, let it be A, B, C, D, and our resultant stress is acting in this direction, that is Px. In which plane? In this plane. Okay. Let it be D, E, F, G. Okay. The Px is acting, we can say Px stress is acting in D, E, F, G plane. Okay. So, this Px is our what? Resultant stress. Due to the Px, we will have P theta and Ps. Okay, we can see the Ps is along the object. So, it can be our shear stress. Okay. Now, we have three stresses, that is Px, P theta and Ps. So, we can say if, as this is making an angle here theta. So, it will be our 90 minus theta. Okay. So, we can say this P theta equals to Px into cos theta and Ps will be Px into sin theta. Remember this. Okay. We have P theta and Ps. Okay. Now, the time comes, we need to calculate the, firstly, the normal stress. To calculate normal stress. So, the normal stress there we can take as P theta. Okay, P theta is our force. So, the sigma theta will be P theta upon area. So, first here till now this to this. Okay, we have taken the area of this part is A. Where? In case of finding, where? In here, where we have calculated the stresses in vertical plane. So, we have already taken this as area and A. So, now we can take the area of this part will be our A dash. Okay, here we have the area as A and A dash. Okay. Now, so our this will be A dash. We will take P theta upon A dash. Why? Now, we are calculating here in this part. Okay. So, now we will take this triangle DCE. Every we can take CDE. We can write it in CDE triangle. We will have cos theta as. So, here if we need to find out the cos theta, let take these two, this as D. Okay, and this is our thickness. So, T. Okay. Here T and this is our D, this is our T. Okay. So, we can say in ABC, in CDE triangle, cos theta will be what? Cos theta will be this CD upon DE. Right or wrong? Cos theta will be CD upon DE. So, we can say that CD is our D. So, cos theta will be D upon DE. Okay. Now, we can write that DE will be what? D by cos theta. Okay. So, in this case, we will have the area, that is A dash will be DE multiply with thickness T. Here we can write that cos theta is equals to here T upon T. Okay, we will take it as equation 1. Now the area will be DE into the thickness. Okay. Here in this diagram you can see this area A will be this D into T, this dimension multiply with thickness. So, this area is our A dash. A will be what? Small d into T. But here we have DE as, we can write D upon cos theta, and our A dash will be dt upon cos theta. Yes or no? Yes. So, in this dt, can we write A dash is equals to A upon cos theta? Okay. So, here to find out sigma theta, we have A dash. Our P theta is what? Px cos theta, as here we have find out here P theta equal to Px cos theta. So, sigma theta will be Px cos theta upon A by cos theta. Our sigma theta will be Px upon A into cos square theta. Okay. Now, we have our normal stress. Normal stress in inclined plane. Okay. So, we have find out the normal stress in inclined plane. Now, we will find out shear stress. In inclined plane. Okay. So, for shear stress we have tau theta. Here. Here you can see this stress is acting along the plane. Okay. So, as it is acting along the plane, we will take PS as the force for PS is the force acting for shear stress. Okay. Now, to find out tau theta, we will use the PS upon A dash. So, tau theta will be Px sin theta. You can see here, PS is our Px sin theta. Upon A dash, we have already found out the A dash is A by cos theta. Now multiplying and dividing. To both side we will have here our theta will be Px by 2a into 2 into sin theta into cos theta. So, we have our shear stress as Px upon 2a into sin 2 theta. This is our shear stress for shear stress in at inclined plane. Okay. So, now we have our shear stress and here normal stress. Okay. So, as I know it is little bit complicated because we are calculating stress and strain in case of compound or complex stress. So, you can take the screenshots here and we will understand from this diagram all those things. Okay. So, in our next class, we will understand resultant stress and in which angle the what stresses will act. So, till now, thank you so much.